Ever wondered how an optical illusion is deciphered by a computer's vision system? How does it differentiate between the object and its background? Well, the answers lie in an intriguing process known as image thresholding, and the use of a statistical tool called histograms. In the realm of digital image processing, thresholding is a simple yet potent method to separate an object from its background. The process involves selecting a threshold value, which then segregates the pixels of the image based on their intensities. Embed dice. Imagine a grayscale image where pixel intensity values range from 0 to 255. 0 represents black, 255 denotes white, and the shades of gray fall between these two extremes. When a threshold value is chosen, let's say 100, all pixels with an intensity value less than 100 will be considered as black and those above as white. This essentially is the principle of image thresholding. But how does one determine the apt threshold value? Well, this is where histograms come into play. A histogram in the context of image processing is a graphical representation of the distribution of pixel intensities in an image. The x-axis represents intensity levels, while the y-axis denotes the number of pixels corresponding to each intensity level. Analyzing the histogram can give insightful clues about the ideal threshold value. Take for instance a bimodal histogram, which has two distinct peaks. These peaks correspond to two different features in the image, say the object and the background. Generally, these peaks overlap, and the threshold value is often chosen as the mean intensity value of the two peaks. So to simplify, if the image has a dark object against a light background, the histogram will have two peaks, one near 0 representing the dark object and another near 255 representing the light background. The mean intensity value of these two peaks could be a good threshold value as it lies in the middle of the two distributions. Now, there's not just one way to threshold an image. Depending on the complexity of the image and the application, a single threshold value or multiple threshold values can be applied. A single threshold segregates the image into two parts, the object and the background. In contrast, multiple thresholds can segment the image into more than two regions, capturing more details. To wrap up, image thresholding is a valuable method in image processing that differentiates an object from its background. The process involves selecting an apt threshold value to segregate the image based on pixel intensities. A histogram, which is a graphical representation of pixel intensities, aids in determining this value. Whether it's a single threshold or multiple thresholds, the choice depends on the image complexity and the application at hand. Understanding these concepts can unlock new dimensions in the field of computer vision and AI development.